Hello, friends. Hi, you can see me now. This is my 67th stream, and today I'm going to work on some hash functions. I've used the SHA-1 hash function in the past, and in Amazon Web Services, and other places too. SHA-2 has sort of taken over where SHA-1 used to be used. So namely, one of the 4 or 6 hash functions in the SHA-2 family, SHA-256. That's probably what I'm going to focus on first. So why am I working on hash functions today? Well, the web service architecture I've been working on, I want to get it basically running a little bit more integrated with Amazon Web Services. So I'm going to want to use their RESTful APIs. Well, they have SDKs for their APIs, but they don't really have one that they support for C++. There's probably C++ wrappers for AWS out there, but I think I'd like to write my own. So AWS API calls have to be signed, and hash-based message authentication codes, along with SHA-256, are used to sign AWS API calls these days, and 256 is one of the SHA-2 hash functions. So I already have a SHA-1 library, so it seems to me like it makes sense to just make the name of the library more generic, like hash, and then add SHA-2 and HMAC to it. So HMAC, I don't know if that's how you say it, but it's a generic algorithm applied on top of a hash function, so we should be able to use it for SHA-2, SHA-1, anything else actually. So there's some nice Wikipedia pages for both SHA-2 and HMAC that we can leverage. They both have pseudocode, so I'm going to rely on that quite heavily today. And they look like this. And why I named the stream 21st century hash functions is because up till now I've been using SHA-1, which was first published in the 20th century, SHA-2, 21st century. So here's the pseudocode for SHA-256. So it shouldn't really be that difficult. I did this with SHA-1, basically turn this into C and make a C++ wrapper for that, and then we should be good. So the same thing for HMAC. They have a similar thing. So it's actually even easier. I wonder if we should do that first. I guess it doesn't really matter. I need some test vectors. Oh, they have a test vector. Well, there we go. Maybe we'll do HMAC first since it looks easier. Start with something easy to get my confidence up just to destroy it when I face the more difficult hash function. Okay, so we got SHA-1 here. And I either need to rename the library or copy the library. Well, in GitHub, it's going to be a copy anyway, so I'm actually thinking I'm just going to copy it. So copy. Can I just paste the whole directory? No, it doesn't. Oh, it did. And it called it SHA-2. Ha ha ha. Very funny. We're going to call it hash. And just go in here and rename stuff. So libraries header path is hash. SHA-1 we're going to keep. README. Let's change this around. This is hash. This is the library which implements various hash functions. Maybe we'll list them, including secure hash function. I mean, secure hash algorithm 1, secure hash algorithm 2. It's actually a family, so it's a set, really. That's called a set. Which is a set of related hash functions described in, there's an RFC for this, right? Let's find it. Okay, that's a C sim for it, or C implementation. Yeah, we'll call it FIPS pub 18-2. Actually, let me do a quick search. And let me do this off screen a little bit. Hold on a sec. Oh, okay. Oops, did the wrong thing. I didn't do that. Copy link address, please. There we go. Okay, yeah, this is what we want to refer to, I think. 4634. That's if you want the RFC definitions. I'm going to just stick with the Wikipedia articles because they have the pseudocode in them. The hash functions are used to compute digests of messages. Each hash function differs in the actual algorithm. Digest size, block size, and other characteristics. And let's also say, let's keep this clause here. The hash of either a vector or a string of data. Well, really, it's the digest. How about we'll say the hash functions can be used to compute the digest of either a string or a vector data. Yeah, that's good. Okay, enough of the README. License, MIT, good. Make file. I'm not gonna. Okay. Not gonna search and replace everywhere because this changes, but this stays the same, and that stays the same. Same sort of thing, same sort of deal here. Yes. Well, this actually turns into hash, doesn't it? These stay the same. They're going to be basically copied from SHA-1. And CMake lists. Add subdirectory hash. All still in alphabetical order, I hope. Oh, I know I should double check something. Okay, yeah. Let me hit update information on my stream. Sometimes the tags get removed, or the tags don't get set. I don't know if it's because I'm forgetting to press this update information button in my dashboard, or if they just kind of get randomly removed. All right, let's see if CMake is okay with these changes. Okay, it's good. Then we build. Couldn't. Oh, the include path is wrong. It's hash now, which is nicer, right? Because it was redundant before. We're getting these warnings. I think it's because we added the files after this. What is the file it's complaining about? CPP properties.json. Compile commands. It's not found in the compile commands. It's looking for it before. I suppose it's before Ninja or CMake is adding them to it. But it keeps happening. I think maybe closing VS Code and opening again as a workaround. Anyway, so let's run all of our tests. We have 17 tests now. And hash test should be one of them. Cool. It's amongst the other tests and it's passing. Where is it? There it is. Okay, so we have a nice base here to start adding the SHA-2 functions. Hold on. Need to clear my throat. Whoa, it's all messing up. There we go. The hotkeys sometimes doesn't work right. It keeps the camera hidden. It should be all tied together. Anyway. Check in now or add SHA-2 and HMAC and then check in? Maybe check in now. Oh, I don't even have my shell open. Let's open that up. And align all the things. Alright. Yeah, let's make a check-in. In fact, let's see if it kept the .git folder. Okay, it did. Do we want to inherit the history from SHA-1? I don't see why not. So we can simply check in this change as a rename to the library. Okay, yes. Alright. Rename library from SHA-1 to hash. Okay. We're going to change the remote here. So remote set up, set URL origin.com, primu8354, hash.git, and then in a crafty off-screen window, do this right. I'm going to go to GitHub, just quickly add that repository spot. So you just do add repository, create. So I created the repository, but really I've just made a place for it because I'm just going to immediately push the entire history there. Push origin, right? Or just git push. I don't have to set upstream because it should have been already set. And now if you go to hash, you see that the history is there. All right. Cool, I'm happy with that. Now that I'm on camera, I have to be careful not to, like, pick my nose. Just scratching it. Get an itch. All right. Time to add SHA-2 or HMAC. Let's do HMAC first. So the HMAC page is here. Doesn't look that bad. Oh. There we go. Okay, so let's make a place for the test. So we'll copy SHA-1 test and rename it to HMAC tests. Add it to the list here. So rename everything. Probably just pick SHA-1 and replace it with HMAC. Okay, so we were generously given some test vectors in the Wikipedia page. So let's copy those over. So here's the HMAC. I'm going to use the existing SHA-1 function to see how clever I am. I don't have to make another hash just to test HMAC. And put it here. And the other one was this key. Or we'll start with the digest. Putting it there. Whoops. Did I paste the right place? I did. That's the empty one. Hey, Rally Monkey. Hi. So the quick brown fox jumps over the lazy dog. Yeah, is it called a webcam or a face cam? I don't know what the Twitch term is. And now, dang it, I have an itchy nose. Look, I'm not picking my nose. I'm just scratching the surface of the outside. Pick my nose. All right. And we'll give credit where credit is due. I pulled these examples from the Wikipedia page. All right. We don't have an insanely long test vector test. We want to include this one too. Yeah. It's the curse of people who have allergies is they have itchy noses. All right. Hash. It's not called a hash, is it? It's called a message authentication code. Okay, they call it an HMAC hash. I'm just trying to find out what is the correct term. Is it HMAC hash? Hold on. Not quite like the arrangement of windows I have. I need like a third monitor to see everything. All right. I gotta be like looking at my cam to see if the lighting changes. This is it. Doing cameras is hard because lighting changes, stuff like the color key changes. But check this out. I got a semi-transparent cup. See that? Isn't that cool? You can have one only $10,000. High tech. It's like a stealth cup. Okay, anyway. What is the word for it? Also, look at this. Part of the mic here is getting a little transparent. I think it's reflecting blue light a little bit. Anyway, I'm getting distracted. I guess we'll just call it an HMAC hash. Or HMAC code. I like code because then hash is sort of ambiguous. We'll call it an HMAC code. That's what we'll do. So HMAC code test vectors. All right. So I think what I wanted to do is just take one of these examples. I guess we can just use the empty string one. Actually, hold on. How does this work? Oh, it had the word bytes in it. Okay, never mind. So yeah, take this string and we're going to convert it into a sequence of bytes that look like that. Let's play with regular expressions. So I'll click within selection, regular expression, and I'll say dot two things, right? Replace with 0x, replace the thing you match. I guess to do that, it's got to be in parentheses, right? And then comma space. Will that work? Look at that. Isn't that awesome? Regular expressions rule. 1, 2, 3, 4, 5, 6, 7, 8. So it's 20. Is that right? 20. You get 20 bytes from HMAC. I guess it's the number of bytes that are in the underlying hash function, right? Yeah, because SHA-256 it's longer and MD5 is shorter, right? Okay. Right, so we need to identify a hash function. You know what I'll do? We'll, rather than having a fixed function like that, let's make a function factory. So it'd be something like const auto hmac equals hmac. I'm trying to think of the right verb. Make hmac function. And then we'll give it the address of a hash function. So let's use SHA-1. So it'll just be the address of hash SHA-1. And then what else does the HMAC need? I think it needs a block size, right? Block size and an output size. So, right, they actually give us the answer there. 64 bytes for block size and 20 for that. Now, I don't know about these magic numbers. I wonder if we could be really clever and use a template of some kind. We'd have to put these numbers as constants in something. And this thing right here is a function. A function can't have constants. Maybe we'll just keep it simple. We'll keep them numbers for now. Think about this later. So yeah, anyway, the thing here is we would do, okay, we need to say whether strings or bytes, right? But we'll call it a string. I need to look and see what kind of varieties of functions did we have. String took a string. Okay, there was 2 overloads for each one. How about we'll have to say like string to string. Yeah. And then for here, we want bytes to bytes. Or string to bytes. All right. Oh, I think that will work. So yeah, we have to define what an HMAC is. So HMAC. Oh, hold on. There's another thing I forgot to do. The library name goes. Actually, there's a bunch of places I messed up here. The library name goes here. Hash goes here as well, and in the namespace. Meshed up. Namespace goes there. Probably in the test too, right? Yep. Namespace, namespace, namespace. All right. So this is hash hmac hpp. Okay. This is sort of a lame thing to say. Let's say declares functions which can be used to make HMAC computing functions based on given hash functions. Use the word function 3 times in the sentence. That's maybe a little bit excessive. Okay, I'm gonna want functional. I actually don't know why standard int was included. Oh no, I do, because of that. Okay. Yes. So let's rework. Let's got this guy. And what do I want? Not there. Want one of these, yes. And it's going to return something that has this signature, so standard function returning a string and taking in this. Simple question, why the directory structure of hash include hash? Don't remember who, but someone asked that question before. Let me try to give a better explanation this time. So, for example, HTTP, and when it declares what it links with, it'll say, for example, URI, right? Well, and in the code, something that uses URI. Request, I guess? No. Maybe in the headers. In the here's where actually we're including the header file. I like this form of an include where it's a directory and then a file name, because I guess it was because my mentor taught me that you kind of don't want to presume that you're the only one that's going to only library that has a header with a certain name. So this kind of gives a namespace of header files, which means that that directory has to be somewhere. And so you could put it directly in the URI folder. In other words, you could put uri.hpp directly in the URI folder like that. But then the include path for HTTP would have to be the parent directory of URI, which would then allow you to maybe include files that you shouldn't be, just because they happen to be there. The directories happen to be there. So we really want to restrict it so that uri.hpp is only in a directory that should be searched for headers. So it has to be in a header directory that's specific to URI. So you would think it has to be in a subdirectory of URI. We have to put uri.hpp, right? So you could have URI/URI/HPP, but I also want to have the directories directly under URI to have standard names, like source for the source code, test for the unit test, and include for the header files. So what I ended up doing to solve all these simultaneous problems is we make the directory include and then URI under it, and then we say our public headers are in include. So this directory, URI include, is one of the directories searched for headers. Thus, we have to have the URI because we want URI to be in the name here, and then the header file. So that's why. It's a combination of wanting this library/file form for include, and then wanting to restrict the search paths so that it doesn't look anywhere other than where the headers should be. What I used to do is just put this file directly in URI and get rid of these two levels. But then, like I said before, the entire top level directory becomes an include path, and so you might accidentally include, you might include zlibplay files, or you might include, private header files. So it was sort of dirty. Yeah, no problem. Right, so this is one of our hash function factories, or HMAC What is it called again? I guess it's just called an HMAC. This is an HMAC factory. Oh, no problem. I don't mind repeating the answer. Every time I get to explain it, it hopefully is a better explanation than the previous time. And what was I calling these? Right, makers. Make, and this is a byte to string. And it needs a hash function, so actually it would be the same form, wouldn't it? Hash function, and then, oh, what was it again? Block size, output size. Ooh, long-winded function. Okay, and then standard, size t, you need standard def. At least I think you do. Usually you can get away without doing that, but... Alright, so that's one of them. I guess we'll document this one. So this function is a factory which returns an HMAC function that takes a vector of bytes as input and produces a string output, computing the HMAC code. Oh, that means there's more to this than a vector, isn't there? At this level, there's two vectors. Or hold on, how does this declared? A key and a message. Then what are these? Oh, they do have two strings. I messed that up. So there's two of them. I'll just keep the types of the two arguments the same. I could get really ridiculous and have, what, 8 different functions? Function factories for all 8 combinations, but I'm not going to do it. Okay, they're not saying, yeah. Camera! I have a camera, so hopefully it's more fun. So what I read is that if you have a face cam, people feel that there's more of a connection, a human connection, and they're more likely to enjoy it or to stick around or whatnot to engage with the streamer. So yeah, I've been wanting to do that, but I had to set up the privacy screen behind me, and I needed to get a better camera and all that. I'm not going to ask for donations. That's okay. I do this for fun. Although this is getting long, I might regret doing this, but I'm gonna break it up. I don't know. I think that makes it a little bit easier to read. It's returning a function that takes 2 arguments and returns a string, and then what it needs itself is a function with 1 argument and then 2 sizes. Okay, this function is a factory which returns an HMAC function that takes a vector of bytes that takes 2 vectors of bytes as input and produces string output, computing the HMAC code for a given key and what's the noun, the other thing, message, using a given hash function. All right. Parameter, hash function. This is the hash function to use to compute digests in order to generate HMAC codes. Ugh, I don't like that. I'm gonna keep the separate lines. Okay, and 2 more arguments. Block size. This is where I might eventually remove these parameters and instead make it some kind of class property. Like there, you would think that there would be a hash function class that has both the function, the block size, and the output size in it, but right now I'm keeping it separate. This is the block size of the given hash function in bytes. And then output size. This is the output size of the given hash function in bytes. A function which computes HMAC codes is the given hash function is returned. And I'm not going to say here the business about, well, maybe I should. Taking byte vectors as input and producing string output. Wrap. It doesn't want to wrap that. Okay, manual wrap. There's some shortcomings to this rewrap. What's it called? Rewrap? Rewrap. It doesn't always work for me. Okay, so that was a long-winded thing. So we're going to have 4 of these, basically. So byte to string, byte to byte. Byte to byte. Wow, that is kind of hard to read. Byte vector output. Okay, and those replace those. Oh, I didn't have all 4 in SHA-1. String. No, I did. I just ate it, I guess, by mistake, or deleted it. You can't eat virtual characters on the screen. What am I thinking? Kind of want to get the order in the same order. Byte string. Oh, I didn't have the string one. Byte to string. Okay, we'll put this third one. Get rid of this guy. Here. This will be string to string. Oh, I forgot to change the names of things, right? String to string. And then this one was byte to byte. And then that last one is string to byte. But forgot to fix the comments here, right? Strings. Strugbs. Stings. Strings. Strings. Okay. Last one. String to byte. I only have tests for 2 of these, but to be pedantic, I would have 4 tests, I guess. But really, I don't know. I'll think about it. I'll think about being pedantic. How about that? Okay, this is vectors returns. Let's copy that. Strings as input produces a, oh, it already says byte vector output. Okay, I think I got it. So we have, mostly for convenience, 4 different ways, depending on if your inputs and outputs are strings or byte vectors. Phew! Okay, so that should have satisfied this, and it did not. Oh, because this is wrong, right? So it's got to be key and message, and then output. So I think that was key, and this was empty string, right? Right, for the long string it was key. And then the empty string was empty string. Okay, got it. Right, it's SHA-1 string. That's hash. And then this is key test vector message. Okay, good. Good, good, good. Oh, wait a minute. It doesn't still didn't like that one. Unknown type. I don't, that's correct, isn't it? Is it because of this ampersand? No, that should be required. I don't know what's going on there. Figure it out in a minute. I want to get through the rest of this. This one was bytes, right? Or is it? What was it in SHA-1 tests? Bytes. Yeah. It's all about what the output you want. So this we wanted a string output, and this one we wanted bytes output, even though we're passing in a string. And that should have been HMAC. String to bytes. Okay, what's misspelled there? Byte to string to string. Oh, I guess it's singular. Oh, wait a minute. This one's not right. This is string to byte. And I guess that wanted S for bytes, which makes sense. So bytes to bytes, string to string, bytes to string. Okay, so everything is good except for this thing. Let's see what's complaining about exactly. Do you have education in computer programming? If so, what? Education? I have a lot of self-education. When I was in school, they didn't have a whole lot of computer programming education. I think they'd only teach Pascal and C, and I mean, the programming part. I mean, I've taken classes for things like algorithms and 3D graphics, but it was pretty long time ago. So, like, they didn't have modern C++ back then. So, since I got out of school, I've been having to teach myself. So yeah, if you mean formal, not really, mostly self-taught. And maybe that's why I can't understand this error message. Unknown type. It doesn't know what the type of this is. Well, let me just guess. When in doubt, guess, right? Guess that is those addresses. Okay. I guess not. I'm going to clear this. Clear it. Is it that the constructor overload resolution was ambiguous? That could be. All these other errors down here are because of that first error, I'm pretty sure. Okay, so what's going on with this? I guess we can do this one. Okay, and there's something I'm missing. This was string to string. Okay. That's the kind of function it needs. And this should be the one I'm providing it with. I don't know, looks the same. Looks the same to me. Actually, let's do a little bit of a trick here. If I say this hash function equals that, what does it tell me the type is? Error type, really? Why is it an error type? Can't deduce. Okay, what if I do this? Okay. Maybe I really just shouldn't. I should change these so that they're not overloads. Let's see what happens if I change this string to bytes, string to string, and now if I try to use string to string, what does it say? It needs to be static. Really? Are you sure? Because I think the problem it's okay with this now. It just I think it was because it was ambiguous. But let me try with this one. Okay, it's old. Try again. Yeah, see, you got past line 30 and it's going on to line 40 now. We can try your thought. So make it static and see what it does. I don't think so because pretty sure static means something else. You're saying make it static here? Pretty sure this won't work, but we'll give it a shot. Clear. It's not a member function, it's a free function. It's just a function inside of a namespace. I'm pretty sure that it's not that it's static or that it has to be a member function. I'm pretty sure it has to do with it being ambiguous. It's overloaded. So if I just make it unambiguous, this is string. So we have string to bytes, bytes to bytes, string to string, and string to bytes. Oh, wait a minute. String to bytes. This is wrong. Bytes to string. Bytes to string, string to string, bytes to bytes, string to bytes. Okay. And then we wanted string to bytes. There. Yeah, see, now it's unambiguous. Yeah, don't feel bad. I get it wrong all the time. I'm constantly fighting with the compiler who knows best but doesn't know how to tell me so. That's one of the downsides of this language. That's why people like to pick on C++, right? One of the many reasons. Now, actually, I'm kind of curious. Can I get away with removing the addresses? I can. Good to know. I think if it was a... This is old. Yeah. I think if this was a like if this was a class and not a namespace, I would need an at there, and then, yeah, I would have to bind it. I'd have to use standard bind, and then address of the member function, and then a object. Like, so I guess with free functions, you don't need the address of operator, the ampersand. All right. So this will not build. Well, hold on. I need to go here and change some of these things, right? This was bytes to string. And this one, if we were to enable it, would be string to string. And this one is string to bytes. That should quiet those errors. It should just have a linker problem now, right? Oh, no, I've missed. Oh, the implementation is not renamed. Bytes to string. String to string. So yeah, this is really just a wrapper for that. And this actually is a wrapper for the other one, right? Bytes to bytes. And then string to bytes. Bytes to bytes. Get one of them wrong? No, this is just old. Huh. It doesn't clear it until I actually hit build up here. Bytes. Oh, it's a string to string. All right. Yeah, so now it's just a linker error because we haven't actually implemented HMAC yet. Let's do that. So this becomes HMAC. This is hash. And I'm going to copy from the header some of the description. The functions. Yeah. I can't claim copyright in the past. What am I doing? This is a new file. I don't know if we need rotate. Okay, yeah, it's all new, right? So remove all this old stuff. Actually, let me... No. Start off fresh. In fact, I'm going to remove this as well. So just let me close this guy. See what we need. All right. Here's the first monster. And so we have 4 monsters. I want to try to do this in a way that 3 of them are just wrap the 4th. So what did I do for SHA-1? Was it Bytes to Bytes? Yeah, Bytes to Bytes was the main one, and all the other 3 kind of wrapped it. So let's try to do the same thing here. So bytes to string. In fact, I'm gonna steal the code from the bytes to string up here. Yeah. It gets tricky because it's a function generator, not just a function. So we're gonna ultimately return a generator. And then inside that generator, we're doing this stuff. The hash function, actually all of these are captured. Or are they? Actually, no, they don't need to be. Right, so inner HMAC. So we'll make an inner HMAC, const auto, and we'll call make HMAC bytes to bytes. Hold on. The hash function is going to give me strings. Actually, I guess we have to wrap it both ways, don't we? Yep. So inner hash, block size, output size. I don't know why I did that. Try to keep into the habit of keeping them on separate lines. It makes the code look longer, but I don't know. Personal preference. I just prefer to have them on separate lines. I don't know why. Inner hash. Right. So const auto inner hash. Here's where we want to capture the hash function. And this. So we're going to unwrap basically the same thing that does the toString, bytes toString. Or was it? No, string to bytes. The string to byte stuff. Oh, I guess I used memcopy, okay. So we want to call it and then convert the data back. So const auto data, and we have to give this a name. Input equals hash function input. And then convert the data to a vector. Then return that vector. So now it's a function that takes in a vector of bytes and returns a vector of bytes, and then we can use it with this. So inner hash. And we don't need this, hold on, let me think about this. Why does it not like the const? Oh, because I forgot a semicolon. Right, so now we have to do the opposite. We have to take bytes and turn it back into a string. That was this code down here, right? Yeah. Ooh. Oh, okay, it was already in there. But it has to take all this stuff. Right? No. This. This is key and that's message. So, first we get the code, calling the inner HMAC with the key and the message. And then it's that code that instead of the a digest. There we go. So it looks, the wrappers are uglier because we have to wrap in both directions. Because we want to use the bytes to, we want everything to be bytes on the innermost. But on this overload, the hash function is going to return a string. So we call the hash function, and we got to convert that string data to a vector. Then we can call the inner HMAC, and then when that gets us the code as bytes, we want to put it back into a string. So in all its ugliness, though, it does fit on one screen. Barely. Maybe not. All right, so the other two wrappers are kind of similar. This is string to string. So ultimately, we want to use the common override. String in, string out, convert string out into vector. then oh, wait a minute. This needed to be a vector, right? Which means, okay, yeah, so this moves. Oh no, I have to do the conversion twice. Ew. Okay, let's make some convenience functions to do some of the string to vector and back stuff. String to bytes. Oh, bytes to string. So confused today. This guy. Input. And then, actually, I don't know why I copy paste. It's going to be a lot of moving around stuff anyway. This is string to bytes. This function returns a vector of bytes that has the same data as the given string. I got to be careful though that there's actually two kinds of strings, right? It could be a string where the bytes are in there as raw character codes, and it could also be a string of hex digits. This is the data raw character codes to no, well I'm doing the opposite. This belongs in the other place. We'll use that later. This is the data to convert into a string of raw character codes. A string of raw character codes equivalent to the given vector of bytes is returned. And again, the rewrap doesn't like to rewrap the return there. Okay. Opposite day. This function returns a string of raw character codes that has the same data as the given vector of bytes. It messed up. No problem. Right, so this is the data raw character codes to convert into a vector of bytes. A vector of bytes equivalent the given string of raw character codes is returned. Okay, and now I'm going to pull into here this common stuff. So this was string to vector. Okay, that's one of them. And then let's use that. We can just say return that data. Okay, and then here's the other one. Okay, this is a third one. Yeah, so we actually have three helpers. Bytes to string, and then bytes to, how about we'll call it raw string, and then we'll call this one hex string. Wait a minute, why did this description's wrong. I what did I... This is totally backwards. How come no one's calling me out on this? I'm supposed to be screaming in chat. You got it backwards. Okay. Returns a string of hex digits that has the same data as, yeah, okay. String of hex digits. Equivalent to the given vector bytes is returned. Yes. All right. So here's what we do for bytes to hex string. Code string builder is sort of a weird word, but I'll keep it. All right, so now we can replace the body of here. So we can just say return bytes to hex string of code. It's a lot easier to read, and I can reuse this stuff now. Okay. So the convoluted mess, which is the string to string version, but internally it's bytes to bytes. It's convoluted because you have to kind of, you can't read it from top to bottom. You have to kind of read it in, out, and back in again, and then back out again. So we need, the inner MAC is bytes to bytes. So it needs a hash which is bytes to bytes. So hash function is string to string. So we have to convert bytes to string and then back into bytes. So const auto input as bytes equals string to bytes input, and then input as bytes gives us the data, and then we have to, how come I didn't like that? Oh, I got it backwards again. Gosh darn it. Bytes to raw string, that's the important part. Input as string. Then we can call a hash function, which is string to string. And the data is a string. So then we need to return string to bytes of data. There we go. Now we have an inner hash, which is bytes to bytes. You said you got it backwards. You thought of this clip from Spaceballs? Oh, let me guess, it's the one where it's like, I want you to call me idiot, not you captain. Right? Get that right? I'm not gonna click on it right now, but I'm pretty sure that's what you meant. Okay, so the inner HMAC, it's bytes to bytes again. And then right, we're going to hold on. Yeah, here's where this changes again. Like both the key and the message are strings. So we need to convert them both into bytes. So const auto key as bytes is string to bytes key, and then the same thing for the message. Something else. Okay, I was wrong. So let me play it.
Beam him down.
Yes, sir. Immediately, sir.
Okay. Oh, he got his head on backwards. Yeah, all right. Trying to keep it family friendly though. So I'm not going to show the rest of that clip. All right, inner mess. This is message as bytes. I could have sworn you were going to say the don't call me you captain, call me idiot. Key as bytes, message as bytes. And then the code is bytes again, and so we need to return it. Bytes to hex string of the code, right? Cool, I think this is actually manageable. So we'll do the third wrapper, and then we'll do the actual HMAC, which you've all been waiting for, the actual algorithm. Okay, so here it's string in bytes out. Right. So input a string, and then we don't need, we can just return the data. We don't need to convert it back into a string. And then inner HMAC returns why does it not like this? Oh, no, we want bytes, right? So we just return code. There we go. All right. Finally, the actual algorithm. Just to get it to build and verify the tests actually catch a failure, let's just have it return an empty array. We should be able to build it and run it now. Unless I screwed up somewhere. Uh-oh. 2 unresolved symbols. String to bytes. Yeah. This is not in the namespace? In the namespace. Unresolved symbol, huh? I think I misspelled something. Make a HMAC string to string function. Namespace hash. Is that the problem? It's not in the namespace hash? Yeah, namespace hash. Oh, wait. I know what I did wrong. I added the source code here, but I didn't change the CMake list to include it. Not headers. Actually, it needs to be in both. This is really only for IDEs, that's why I don't need that, but if you were to make a build system for Visual Studio, you might want to see that file in Visual Studio, so where we list it to be nice. So, all right, build. Oh, did I forget? I forgot a return somewhere. Line 31. Oh, I didn't even implement that? What happened? I thought I had that. What happened to it? What'd I do? Okay, well, we can recreate it. That's we can grab it from here. Bytes to raw string is one of the things we did up here, right? Yeah, this one. No. Oh, actually, I guess we didn't do it. Oh, no, here we did it. Yes. Oh, no, that's different. Wait a minute, did we never... I guess, okay, that's why. SHA-1 never needed to convert a vector of bytes into a raw string. So this is, so we have to do this basically from scratch, but it's similar to string to bytes, we're just going in the opposite direction. So it'll be size and actually I'm just gonna use the initializer list constructor of string. So you use braces instead of parentheses, and then you just, it takes an iterator, begin, end iterator pair. You can just do that. Maybe not as efficient as a mem copy, but That's good enough. All right, so I'm gonna run it in this standalone shell, simply because I have a little bit more control and a little more space to see it. Hash test. All right. Bad function call. Really? Okay, so maybe we need to run that in debugger and see it. So debug, make a debug configuration. Launch. Hash tests. Hash, okay. Hash test, go! What happened? Oh, it didn't crash hard. It just hit an exception. I need to figure out how to tell this to stop at exceptions. Actually don't know how to do that. Okay. In Visual Studio, you could open up one of the debug windows was to list what exceptions to stop at or to just continue. Let's see if it's got something here. Except, no. Nope. I guess not. What does it give me? Really limited in what it can do. It's happening, like C++ exceptions, but I don't know, like, there's no way to break when you, apparently there's no way to break when the exception happens. And thanks for following. Okay, well, what can we do? I could just give up and go back to Visual Studio for this. Not really giving up. I have set aside another build directory for running in Visual Studio. We'll just do that. Actually, I haven't done this in a while, in at least a couple streams. So I actually don't know what the stuff looks like in Visual Studio. We shall see. Alright, doesn't look too bad. Actually doesn't look that bad at all. Okay, so I can say hash test is our startup project, and I guess we'll just want to build everything. Oh, this is doing release build. Yeah, we're going to want to change that. Build. Well, I can let it build. It won't take too long. I just need to change it to debug configuration. This text here is sort of getting harder to read when I'm in this window, isn't it? 150 followers? Yay! I do a little jig. Okay, so debug. Yeah, so anyone new here, I like to make my own libraries almost from scratch. Stuff like encryption I'm not very good at, so I don't make it from scratch, but I like to show writing low-level components like protocol handlers like HTTP and hash functions in C++ and using test-driven development. So I'm not really looking for doing this for a living. It's all for fun. So no way do I expect anything. Follow if you like it, and then it'll be cool. So a lot of streamers are like setting milestones and asking for subs. I don't like to do that. Okay, we're gonna build. Okay, all built. Let's just debug. Hopefully this will stop on the exception this time. It didn't. So here's where I want to go into exception settings. This is the thing that's missing from VS Code, and click on that checkbox, then hit go. That's what I wanted to see. So the inner HMEC is empty. Oh, did I make the function and just not return it? Oh, that was supposed to return something, and it returned a null function object. Okay, I was just being dumb. So let me go back to VS Code. Since I know what the problem is now, I want to try to use VS Code as much as I can because, yes, I want to save it, because it's the same tool on Linux and the Mac, whereas with Visual Studio, pretty much have to go back to Windows to use anything there. I want to have the ability to go cross-platform if I need to. All right, so the problem is this is too dumb. So I really want to return a function which does nothing, but has the correct signature, like this. The correct signature would be this. Right? How come I didn't like it? No suitable. Oh, I have to, okay. I have to say return that. And I might have to be specific about the type, which is fine. There we go. So it's unambiguous. Okay, now hopefully it shouldn't throw an exception. It should just fail the test. So the thing about test-driven development, right? You make the test first, then get it to compile, then link, then run the test. The test will fail because you haven't written the code yet. Then you write the code, and if you've written the code correctly and your test was good enough and descriptive enough, then you know you're done. So, right. Essentially, it's failing because it's expecting an actual HMAC code and we get nothing out, right? So, again, we're finally to the meat of the thing, the heart of the deal, where we're going to implement an HMAC routine from pseudocode. It's actually pretty easy at this point because pseudocode is pretty close to C. I can just kind of look at this and say, okay, we need to do this extension or hashing of the key. And then we do these XOR operations, and then we call the hash function a few times. All right, so let's do the first thing. So keys longer than a block size have to be shortened. Cool, no? So we say if, we have to give these names, key and message. So if key dot size is less than, no, it was greater than, right? Yeah, greater than block size, then we're gonna need something to, we'll have, because it's replacing the value of key, so we need a local variable. What do we call, what's a good name for it? Normalized key, and it has this type. Normalized key is hash function key. Oh, and for this, we basically need to capture all of these things. Right, so if it's greater than that, else if it's smaller, we have a different problem. Or actually, I can combine the smaller than and then the implicit do nothing in either case by just padding. So yeah, so we'll do an if, and we'll say, I mean we'll do an else, and we'll say while. Oh, hold on. So normalized key equals key, and then we'll say while normalized key size is less than, yes, then we will, I think it wants me to add zeros, so normalized key pushback 0. Actually, you know, there's an easier way to do this. We can say normalized key resize. Block size, right? It'll do nothing if it's already block size, otherwise it 0 extends it. That's what resize does. Technically, it has an overload where you can give the default value, but this overload just uses the default value of the type, which for size t is going to be 0. All right, so that's first step done. Second step is we make the O keypad. Actually, they call it iPad and OPAD. I like those names better. So iPad and OPAD are taking the key and XORing it with just a sequence of constant bytes. So let's do that. vector. Oh, why type when you can copy, right? iPad, OPAD. Why don't we just make copies? Normalized key, right? And yeah, we can say for auto, and then this is important, reference, I don't know, B in iPad. Not the Apple iPad. Not the Apple iPad. It's the, I don't know why it's called I. Inner padding. The inner padding. We XOR with B5C. And then the OPAD. We XOR with 3, 6. And if you're curious why those numbers, it explains somewhere down here that they are used to, oh, I don't see it. They're used to make it more secure, to hide the key a little bit better. Additional rounds of hashing and all that. So inside out, or I guess we could construct it the same way they do. Yeah, why not? Why not? So it is return hash function of OPAD plus. Actually, we can't add vectors. We can't add vectors, so I can't do a nifty thing here unless I made a. Actually, let's see what happens. What happens if you try to add vectors together? iPad plus message. No operator plus. We can make one. Let's do that. This is going to be scary, but we can make an standard vector unit 8t operator plus, and then we have 2 arguments. I'm surprised that this just isn't in the standard library. We can make one. We're dangerous now. So essentially, what this should be const. We don't force a copy to be made. So we should make it the size. Well, hold on. We can start off with that. Actually, what's better? Starting off with left-hand side and then resizing and inserting the right-hand side, or should we start with reserving space for the sum of the 2 sizes and copying them? Let's do sum of sizes. Then there's only 1 memory allocation, right? So we can say standard copy. Standard copy is an algorithm, so we should be nice and include it. So copy, left-hand side begin to left-hand side end, and does the destination go first? Destination goes last. So destination is result.begin. Okay, and the standard copy, right-hand side begin, right-hand side end. Result.begin plus left-hand side size. And then we return result. So there we go. We hacked in our own plus operator for vectors. This function concatenates together 2 vectors of bytes. This is the left-hand vector to concatenate. I have a hard time saying words like concatenate unless I slow down. The also typing it too, concatenated How about we'll say the vector formed by concatenating the two given vectors together is returned. This thing ought to be in the standard library. I don't know why it's not. But see, now we can do something cool like this. Now let's see if I did it right. If I did it right, the test will pass. If I did it wrong, the test will fail. And I did it wrong. What did I do wrong? Well, it's actually really long, so I probably have the sizes wrong. It actually looks twice as long as it should be. And they're all decimal, which is suspicious to me. I wonder if it's printing out decimal numbers instead of hexadecimal. Okay, let me look at the actual test, because it goes through those. It could be the hash, the HMAC, or it could have been one of those wrappers I made. Okay. So both of these vectors failed, and it's the string to string. Okay. Bite the bullet and look into it, I guess. Let's first gonna do both of them to bytes, then the inner HMAC, then bytes to hex string. I'm suspicious about this bytes to hex string, so let me look at that. That's my suspect, I think. So what is that code? 40. Is that the right length? 40 bytes? No, shouldn't it be 20? Oh, look, they're already hex digits. That's the problem. They're not bytes. Yeah. See that? It's twice as long because they're already hex digits. So this inner HMAC is, this guy is converting into hex digits somehow. It shouldn't have. What's that? Inner hash. Let me restart and look at that. Well, the hash function's already giving an a hex. Hold on. Oh, that's right. Yeah. I made the mistake of thinking that hash functions that return strings are returning raw strings, but they're returning hex digit strings. So I need to be more careful about string to bytes. There's raw string to bytes, but then we also need a hex string to bytes. String of raw character codes. Okay, yeah, and this turns a vector bytes that has the same data as the given string of hex digits. Hex digits. This is all the cost of wanting to be convenient for our users so that we can let them pass in strings or vectors. I saw my blue screen flap. I've learned this weekend that it's really tricky to set up a green or blue screen to get the color key right. More tricky than I thought it would be. Okay, anyway. Hex string to bytes, we gotta be it's a little bit different. It's half the length of the input. Right? And we can't just do memcopy. I think what we'll do is we'll say for size ti equals 0, I is less than data as vector size plus I, and then we'll say the two codes. So let's just get the code, or upper const auto upper equals input I times 2, and then const auto lower is input I times 2 plus 1. If upper is greater than 0, I'm wondering if I should cheat and just use scanf. Or maybe I've already done this. I should look for code that looks like this. I have a feeling I've already done this, so let's look for it, if I have. Well, zlib did it. Chunked body did it. Oh, but it was built into a larger state machine. LibreSSL does it a lot. Again, the 2 number has some of that built in. Okay, so I didn't do anything exactly like this yet. Okay, fair enough. Let's be gracious and accept both uppercase and lowercase. Or actually, we can say 2 lower, right? We can make our code a little bit easier. Hey, Dark Passenger. Do I look like someone important? What am I working on? I am making... Hold on. I'm making my own wrappers for SHA-2 and HMAC, because that's what I kind of do on this stream. I make my own sort of reinventing the wheel in C++ for lower level libraries like hash functions and web server, web client stuff like HTTP and WebSockets, that kind of stuff. So today I'm working on a wrapper for HMAC, and HMAC is used along with SHA-256 for signing Amazon Web Services API calls, which is what I want to do because I want to write my own wrapper for that in order to integrate more closely with Amazon Web Services and my web service architecture. So yeah, this is like my 67th stream, and my earlier streams I worked on making my own web server. So I have a web server, and it has cool stuff like TLS support and WebSockets, and I want to kind of use it more on Amazon Web Services. So that's what we're working on today. All right. This might be a little bit confusing. How about, because I'm saying upper and lower. Can I just loop twice and call this? Yeah, let's loop twice. For, it doesn't matter, auto digit in. Yeah, we can be cheeky here and just say input dot substring I times 2. Yeah, we'll be cheeky, and then we'll say U8T is the byte. Let's initialize it, and we will shift it up 8 bits, and then we will add to it the typecasted version of, I need to make a digit instead of upper. Digit minus 0. By the way, if anyone is doing a class in C++, this is a potential thing you might be asked to do in your homework and lessons, is convert between hexadecimal strings and actual data. And that shouldn't be an F. It's all about knowing about how you can convert between characters and numbers just by subtracting the base character. And then you don't forget to add 10 for the A through F. right? 0 through 9, and then 10 is A, 11's B, 15 is F. That's how it's the core of hexadecimal, right? All right, after we loop twice, then we can store that, right? Actually, I don't even need a buffer here. I can just say auto. I can just say auto byte equals data as vector I. And then it directly puts it into the vector. That's address of, right? And we don't do that anymore. Okay, now I need to make sure I use the correct string to byte. So this is if it's the output of the hash function and it's a string, it's a hex string. Where else? Okay, here hex string again. Here it's the opposite, right? It's the key is a raw string, so and the message is a raw string as well. Raw string. Okay, let's see if I fixed it. Doing test-driven development. So, oh, I already made a mistake. What happened? Did I not see that? I didn't see that. There are two of them, and we built up a test, two tests first, and then we wrote the code, and we're trying to get the test to pass by writing the code. All right. So the format's correct, but the codes are not correct, and I think it might have been the way I did the hex string stuff, because every other one is a 0, and that makes me suspicious it's something to do with this code I just wrote. Yeah, new cam. Hi! I have to look over here to see my chat window, by the way. That's why you see me glance over here. In vain. How's it going? Shift left 8, right? And then we put in the byte, and then we should get one more call, so it'll shift the first digit up. And then or in the second, or add in the second one. Anyway, let's see it in action. So debug go. So data as vector. Right, in the input. Okay, cool. Actually, let's see if it gets the answer right just by telling it to go. The input is 92. Oh, wait a minute, that's already okay. Right, hex digits, right? 92 should be the first byte, and it's not. Okay, so obviously this code is wrong. So rerun. Working on HMAC auth, and I have no idea if that's how you say it. HMAC is what I'm calling it. So let's see, what did I do wrong here? First byte, first digit is 9, correct? So it's a 9. So shift left 8. Is that the part that's broken? Oh, it's not 8. What am I thinking? It's 4. A digit is 4 bits. That's what it was. Stupid mistake. But it kind of is a good thing I made a stupid mistake, right? I can show you how you go about debugging something like that. Okay, what did I do wrong now? It's just a wrong code. So, I don't know. This could be something I did wrong in HMAC stuff, right? Yeah, so let's go to debug mode, get rid of all the breakpoints we have. Let's go into the inner HMAC thing and see if I can find out what I did wrong. So here it is. Go. Okay, so the key is just KEY. Wait a minute. Is that correct? Yeah, the character code's KEY. Or show the test. Right, so here's the key. It says 3 byte long KEY character codes, right? So the block size is 6. Oh, is that bytes or bits? That might be the problem. Actually, I think it is bytes. I look like someone who is not at all important. You should grow a beard. You'll grow a beard like me, and then you'll like get nervous habits of pulling out, or your beard will grow gray like mine. Looking like an old guru. Let me look at the Wikipedia article. Make sure that this was bytes. Okay, it is bytes. So it should just hash it. No, it doesn't hash it because it's less than, it's shorter than, so it's going to pad it with zeros on the right. So normalized key is key and then 0 padded. Okay, good. And then iPad starts out with key. And now it's K with that XOR mask. An O key, or O pad, outer pad, that same key with a different XOR mask. So it should take the inner pad and concatenate the message to it and call the hash function. So step in. Just put a breakpoint there. So if the left-hand side was that inner pad, right? And then the message was a quick brown fox. So the result is the pad followed, appended to it, the message. Okay. And then that should be hashed. Oh, what happened? We skipped over the hash function somehow. Okay, so let's restart. How do I go to that line? Double clicking there doesn't go to the line. Damn it. I think that's the correct place though. Right, because I need to, I guess, find the hash function and put a breakpoint in it. I guess it would be here. Go. Okay, so the data is our inner pad and the message, right? And we tested this. This hash function does work. So there's the digest. Oh, wait a minute. It's putting it into a hex string. Maybe that's the problem. Okay, yeah. It's not. Here's the hex data 922B, right? I wish I could have it shown in hexadecimal. But I think 92 hex is 146 decimal, right? Handy old calculator. 92 is 146, okay. Just gonna guess that that's right. Okay, so it should pad, it should do the outer pad now, and should go back into, right, going back into the hash function again. No, it does a concatenate first, right? There's the outer pad, and then the inner hash. There's the digest. Actually, here I can now compare with what it should be. DE7C. I don't think that that's right. No. It's already wrong. Shoot. So I did something wrong here. Where's output size used? It's not really. Why am I even passing it in? I was using block size. Second byte is 19. Is that what we're seeing? Yeah, 19. Okay. Well, I'm just looking for things I might have done wrong here. Padding zeros on the right is what we did. 5C and 36, are those the codes we used? I say we, like, because you guys are coding with me, right? 5C and 36 hex. Yes. Oh, wait a minute. Hold on. I swapped the I and OPAD. That's what I did. OPAD is 5C. iPad is... Oops, that was me accidentally hitting my privacy key bind. Yeah, okay, I had these swapped. I should really put them in the order in which they are in the pseudocode so I don't get myself confused. So we have O first, XOR. Okay, got it. That's probably... Hopefully that's what I did wrong. That's what it is, though. That's a programmer life, is you're just looking for silly things that you did wrong. Hey. It's always nice to see your unit test pass when you finally figure everything out. Alright, so we have passing test vectors. It'd be nice to have more test vectors. Although, it'd be really hard to get this one correct and then screw up another combination. And we have these two vectors at least. So, oh, thanks for the bit, SourceFi. Didn't know you were here. Yay, so we have HMAC done, and maybe we move on to SHA-2, but let me check this code in. So, there's a bunch of different commits though, isn't it? Maybe it's just one. No, we did change this. Let's do this change first. This change is essentially disambiguating the names of the previously overloaded functions, right? SHA-1 disambiguate hash function names. And then this was just adding HMAC in one check-in. It looked like a superstar where I only needed one commit to get it to work. Add HMAC. I'm just joking. There's always going to be something that or other people find wrong with it, so you never get perfect on the first check-in. Okay, so let's do SHA-2. SHA-2 also has test vectors, so we can start with that. And I'm not going to do all of SHA-2 unless I end early. Unless I get through this lightning quick. I think I'm just going to do what I need for Amazon Web Services, which is SHA-256. That's weird how they have a 0x there. They didn't do that in the other page, did they? They didn't. Inconsistency. Probably not the same guy who did it. That's probably why. All right. Hash. Oh, let's go to here. How come this says oh, I did modify something in the root. Yeah, let me address that. Right, so Mugget says that hash is a new repository. So I'll do Mugget add hash. And then there's Mugget doesn't yet, I say this every stream. Mugget will add the line for hash in the manifest I'm using, but it won't add it in the manifest that I'm not using, which is this HTTPS version of it. So I have to do this manually right now. There we go, we added hash, so we can say add hash to solution. So it's get ignore because it's a subordinate repository and it's not a submodule. Add it to our build framework and then add it to our manifests. We'll push that. All right. I'm out of tea. You want to see my fancy $10,000 transparent cup? See, look, you can see right through it, right? In fact, it makes me invisible. All right, enough of the green screen jokes. Actually, my green screen color key isn't quite right, is it? It changes as it gets lighter or darker in the room. Let me play with that a little bit. Get rid of those dots. All right, we'll go with that for a while. Okay, so SHA-2. We can close SHA-1. We don't need to see SHA-1 anymore. Actually, I might keep SHA-1 around just to cannibalize. Right, so take SHA-1 tests and rename it SHA-2 tests. And then we'll add it to the files to build. And then place SHA-1 with SHA-2. All right, but this will be SHA-256. We don't have an insanely long test vector for SHA-2 right now. Okay, let's call this one SHA-256 test vectors. I think that's what I had before. And then SHA-256. Sure, we'll leave the name sort of the same. All right, so this is SHA-256 string to string. 256. Where am I getting my test vectors? I'm getting them from Wikipedia, of course. Actually, I wonder if this Australian website, I think that is, has vectors for 256. Maybe look there later. Let me make a note to remind myself to do that. So, look for more test vectors. Maybe the same Australian site that had SHA-1 vectors. Okay. We have the empty string is this one. And then the other one, actually we have, oh, that's 224. Oh, shucks. We just have one test vector? I don't like that. We can make our own test vectors, actually. If they don't have more here. Because I happen to know that there's hash functions in Openssl we can do. Okay, so yeah, I think that's what I'm gonna do, because I don't like one test vector. That just makes me afraid. And this is sort of lazy. Why would they only have one? The HMAC had at least two. If we were doing 224, we'd have two extra vectors here. Okay, so actually, let's just ditch the test vectors and we'll say that these test vectors were obtained by calculating SHA-256 digests using the great and powerful Openssl tool. Right? Because if we just make a file, let's make a file in our build directory. Make a new file called empty text, and it's just empty, right? And then we make another one, and we call it Fox. And then I like the quick round Fox, so we'll just copy that. Okay, the text editor thing insists on adding a new line. Should I temporarily sabotage that? That's in editor config. Put that in there because a lot of times I forget to do this. Insert final new line, false. So it's sabotaged. Save that and then close it and then put this back to where it was. Cool. Hopefully that doesn't have a new line in it. Well, let's double check. Type empty. How about... I believe that stands for octal dump. So there's no bytes in it. Oh, Fox. I don't know what foo... Oh, that was from another thing I was playing around with. The gzip thing from the other day. So, octal dump gives us the raw bytes to make sure it's exactly right. Space DOG. Correct. Alright, so we have some vectors to play with. So I should be able to just say Openssl SHA-256. Is that how you do it? What am I doing foo for? Empty. There we go. And then Openssl SHA-256 Fox. Cool. So there's our test vectors. So there's empty string. That should match the one from Wikipedia. I think it does. I want to look at every hex digit. I just looked at the first 2 or 3 on the beginning and the end. So 52B855, right? And then beginning E3B0C4, E3B0C4. Okay, good. So I can close that. So we already had that. Box. And then we can put more if we wanted. But I'm not gonna. Quick ground Fox. Cool. And then, I don't know, maybe we should throw ABC in there just because we can. No, I'm not gonna. I'll do the empty string one, like I did for the HMAC. And I'll just do this trick. Should we do this again? This was fun last time. So Control H, and then this one, find in selection, and then regular expression, make sure that's on, and then we do, for open parentheses, dot curly brace 2. And then we replace with 0x, and then %1, which is the contents of what it matches in the expression, and then comma, space. Replace. I like it. 1, 2, 3, 4, 5, 6, 7, 8. Let's break on 8. So it's 32 bytes long, is that right? 256 bytes is 32 times 8? That sounds right. 256, right? Yeah. So it's called SHA-256 because the digest is 256 bits long. Okay, so our tests are set up. That was step 1 of test-driven development. We're happy with these tests, right? So why is it showing... When I click away from it, it's showing it in gray. I wonder if that's because we haven't rebuilt CMake yet. Probably. So before we do that, let's make placeholders for these files so that it'll actually build. Actually, look at that. Here's the one and only time where copy paste will actually give you the correct file name. The only thing it didn't do for us is that it didn't go in the file and replace it inside the file, but that would be asking a lot. 256. So this will end up, if I get to it, I'll end up putting in the other SHA-2 functions, but for now it's just going to be the 256. Yeah. Oops. I wanted to capitalize it in that case. Why don't I just do this? Need to get more used to that multi-cursor mode. All right, and then in here. Oh, hold on. I noticed the copyright's still wrong. It's 2018. Oh, did I missed that. I missed a few places where the whole namespace used to be called SHA-1, but now it's called hash. Let's see if, oh, and there's a space. Look, I'm noticing all these little things I missed last time. Okay. Hash. Does this have the same issue about the space? It does. I think we're gonna need the rot those bits, rotate. But I think actually I was saying earlier it's rotate right instead of left. Where's the pseudocode? Here it is. Yeah, they have right rotate. Well, they also have a right. We can do right shift intrinsically, right? So this was left because I believe SHA-1, if we look that up, its pseudocode wanted us to left rotate. Yeah, left rotate. So we're gonna be, so we're doing SHA-256, and that's right rotate. Right. Yes. So it's the other way around, isn't it? I think that's all we need to do there. All right, 256, 256, 256, and then one more. 256. Oh, and then the wrappers all need to be replaced. Or the wrappers need to be fixed up. And then everything should be the same for the wrappers. In fact, it makes me think maybe we could have a template to do this for us. That might be another refactoring step, because if we made a template class, we could kill two birds with one stone, so to speak. We could have the template make these wrappers for us, and then we could also have the template provide the numbers that we needed to provide here. Actually, we don't need this number at all, right? The output size. I actually don't know. Anyone happen to know why in the pseudocode for HMAC it actually bothers with output size? It never uses it. Block size, yeah, it uses it there, but where does it use output size? I don't see it. And isn't this a bug? It's not that it becomes output size bytes. Doesn't it become block size bytes? Hold on, am I not understanding something here? Is this a bug that it says output size and not block size? Or does the hash actually return output size? Wait a minute. What? What? Did I do something wrong here, but then end up matching the encode as a result? hold on. The block size... It would have only gone up to output size, not block size. I think this code is wrong. I think it's supposed to go... Hold on, wait a minute. Right now, it's going through this path. Right, 0 padding up to block size, which is 64 bytes. Which is correct. Oh, wait. I do have this wrong. So it should go into this after it goes into this, shouldn't it? So what would be a good test of that? There's like an online HMAC where we can put... We'd have to have one that's bigger than 64 bytes long. A key that's longer than 64 bytes. It's going to fail in my HMAC because it is going to hash it, but then not 0 pad it up to the block size. Because this is correct. It goes up to output size, which should be 20 bytes. But then it has to additionally 0 pad. Why do they do that, by the way? So if you have something that's 25 bytes long, it'll hash it down to 20 and then 0 pad it up to 64? Why do that? No. I'm not understanding. Anything between 20 and 64 will just be 0 padded. If it's more than 64, like if it's 65 bytes, it'll get hashed down to 20 bytes and then padded with 44 zeros. That just seems weird. Okay. Who am I to argue with algorithm, guys? Anyway, this is bad because if we have a key that's 65 bytes or longer, it's not going to do the right thing. It's going to end up with a 20 byte pad instead of a 64 byte pad. Yeah. Let me fix that first. So in order to fix that, let's stash what we had. Stash that guy. And make sure this still builds. And runs. Okay, but now let's find a. I need to find. Let me go off screen here for a second. HMAC online. Okay, here we go. So I want a key that is. I want a 256, and I want a key that's. Let's do the quick brown fox for the message. Actually, let's verify that this actually works. So we'll put the quick brown fox here, and the secret key will be key. Beat HMAC. F7. That's not right. Oh, I did 256. I should have done SHA-1, right? Yeah, DE7C. But I bet, so if I make a key that's longer than 64 bytes, how long is the quick brown fox anyway? 44. So we need something even longer. Let's just form it up here. I'll just type some random stuff. Cool, 91 byte, or 90 bytes, really. It adds 1 for the null character. You can tell because if I hover over key, it says 4, but we know key is a 3-letter word. So, yeah, it could be any byte, so it can have a semicolon in it. Why not? So if that's our secret key, and we do SHA-1, that's the code we should get, right? But I bet that's not what we're getting. I bet this will fail our test and then we can fix it. Yep, see? That's why I shouldn't have settled with only 2 test vectors. Okay, let's fix it. I think the fix is you don't go into this else. You just repeat if key size is less than block size. And we should actually be using not key, but normalized key. We should just initialize it with key. Like that. And we don't need this equals. Which means we don't need this compare. We always just resize, right? Yeah. So I guess the only reason they put output size in there was to use it in this comment. I think that's kind of silly. But anyway, that should, hopefully that'll fix our test. Yeah, okay, good. Okay, I feel better that we fixed that before moving on to SHA-2. Thought I stashed. Oh, stash doesn't stash untracked files, I guess. Whatever. There's the new test and there's the fix. So HMAC. Fix HMAC code or fix. Really it's inner key calculation or derivation. Keys longer than the block size were being hashed, but not 0 padded back up to the block size again. Cool. And then git stash pop. And now we should have CMake list changing for SHA-2 tests. Yes, okay. So where were we on SHA-2? Actually, we can keep this exactly the way it is, and it should just fail our test because it's doing the wrong hash function. Right, so it's missing the hash function because I did not add it to the outer CMake list, right? Yep. So include hash SHA-2 HUV, source SHA-2 CVP, and then CMake build. Oh, my color key's acting up again. Color key. Did you get those? See at the top of my camera? I'm playing with right now. I want to get it so that it disappears, but if I go too aggressive, then my face melts away. Somewhere between the weird pixie dust on the top and face melting. So a good compromise. Okay, it's a little bit of eyeglass melting. Pro streamer here, by the way. Oh, hey there, Murdium. Yeah, with face cam. Hi, you can see my ugly face now. I think we can test this now. It's not going to work because we have not actually put the correct hash function in there, but we're ready to put the correct hash function in there now. So, SHA-2. SHA-2. Right, so all of the boilerplate is taken care of, which I think I do want. I think I do want to make that a template. So let's make a class template for hash functions. So the advantages are template can hold block and output sizes, useful for HMAC, and the second thing is template can provide all the boilerplate. So byte to string, string to byte, etc. Okay, so we're going to say that this is a straightforward implementation of the pseudocode found on the Wikipedia page for SHA-2. And then here's where I'm going to convert the pseudocode into C code. There's a lot of similarities between SHA-1 and SHA-2, right? In fact, they even say so. They say, note the great increase in mixing between the bits, but obviously they mentioned it, so, and the code follows around the same thing. So we're going to have hash values 0 through 9. So it's basically doubling. We only had 5 before, now we have 8. So it's not exactly doubling. And then IntelliSense is fighting me. We're doubling number of bits though, right? No, we're not. It's still 32-bit. If we go to when we go to SHA-2 512, I think it's double the size of the variables in bits. So I'm just manually copying all the constants here. One thing I found interesting reading this is, like, how did they pick these constants? And they actually tell you they are the first 32 bits of the fractional parts of the square roots of the first 8 primes. I think it's just math people having fun. Because they're like, well, we have to put something there. It can't be all zeros. It can't be pseudo-random. Hey, we like prime numbers. Well, what if we do the square root of the prime numbers? And then we'll take the fractional bits. I'm making fun of math people. There's probably a real good reason why they have that selected. Probably something to do with the probability of it being brute forced. Okay, so this round constants we didn't have before. Those are not modified, so really that's just a table. And I'm just going to cheat and do this. Copy, and then we will paste it here. So static const un32 k, and we'll do a size check. It's exactly 64 elements, and then we put them in here. And do I care that it's a little wider than yes, I care. So this 64 is kind of nice to have, because if you had an extra one, yeah, you get a red squiggly down here saying it's too many. And if you accidentally had too few, it tells you. Oh, no, it doesn't tell you. Okay, it's only if it's too many. But we can do that as a quick check to make sure that we have the correct number. If we go 1 over, it's too many, right? Exactly 64. Good. All right, pre-processing. Here's where I'll probably make some mistakes, because it takes a bit of thinking. So we begin the original message with length L bits. Yes, we do. Message length, it's L bits. Append a single 1 bit. I'm trying to implement SHA-2 function? Yes, I'm trying to implement on my own. Should I be worried? Actually, I did the same thing for SHA-1, so I'm just repeating it for SHA-2. Append a single 1 bit and then append a bunch of 0 bits. So what that tells me is that we'll have to add at least 1 byte, right? Because it's got to be units of bytes. It's got to be a multiple of 512. So we're going to, I think I already did this before. We added a 0x80 to it at some point. Nope. We have to append a single 1 bit. Our input message is always a integer and multiple of 8. And if our output has to be a multiple of 512, that means we'll have to add at least 7 0 bits, right? So can't I just add a 80 hex byte to the end? What am I doing here? This is leftover code from SHA-1, by the way. Let me see if I can understand what I was doing here. Oh, okay, this is the number of blocks. Right, so here's the extra 1 bit and then the extra length. So it's a similar thing. So we just need to compute the number of blocks that we'll have. Right, so we're adding at least 9 extra bytes. Right? Because we're adding the byte that has this 1 bit in it, and then we're adding 64 bits, which is 8 more bytes at the end. So we're adding at least 9 bytes, and our block size is 64. Right? 64. I should be able to do this in my head. Just if we go to decimal, 64 times 8. It's 512. Yes, 512. So yeah, we're breaking it into 512-bit chunks. So this logic is actually still correct. This logic from SHA-1. So all of this should be good. This is saying if the whole chunk is within the data itself and not into these appendations, then we just do a memcopy of the data from our current offset into this chunk buffer, 64-byte chunk buffer. Otherwise, we zero initialize it, and then if there's still data to read from the input, we do that. And right, this special if is for a corner case. If the offset is either less than or exactly equal to the number of bytes of input, then we go to where that appended byte should be and put it there. And then if we have room, right, basically I think this if we don't need to do, I think this is always true. The last block will always have these bytes in it, right? I think it's guaranteed. I don't think we need this if, but it's maybe a safe thing. It'll always be true, probably. Oh, my color key is acting up. I don't know if people really care about this, but I'll risk having semi-transparent glasses for a while. How about that? I don't like that, though. Just get my chair closer or further away. Actually, if I do that, but then I smooth it. Okay, we'll go with that. Semi-transparent glasses. Sorry about that. Eventually I'll get better at this camera stuff. Alright, so next part of the algorithm. "64 entry message schedule array." So it's 60. Oh no, the first 16 words, and this we extend it with 48 words. So that's what this is doing, right? First 16 words is just copied verbatim from the block. Then, why does it say 80? Did it used to be 80? Okay, it was 80. It must have been 80 for SHA-1. Yeah, so W was 80. Where does it say that? 80. And instead, it's here 64. So 64. 64. All right, maybe I'll just copy this over as a little cheat sheet. Just temporarily. Wow. Okay. No one's going to look at this code, so I'm just going to plus, and this is S0. Actually, let's make it somewhat readable. Different components in it. S0 is WI minus 15, rotated right 7, XOR, rot WI minus 15, 18, rot, or XOR rot WI minus 15, shifted right 3. Oh, shifted. So not rotated, but shifted. And then the S1 term is 2 here, 17 bits rotated. 2 there rotated 19, and then 2 there shifted 10. Okay, so it's a 15 term, said 3 times. Just rotated differently and then shifted. This makes me curious how the math works. I believe, by the way, it has something to do with their awesome picture up here. Is there a better one? That one's teeny tiny. Okay, yeah, this. I believe if we look closely enough, we'll see that those constant. This might be a later part of the algorithm, but I think the point I was trying to make is diagrams like this and this are a hardware-centric way of sort of expressing this kind of thing. Although I think that what the picture they're actually talking about is further in the algorithm. So when you get down to this main loop, you can see it's sort of the same deal. It's just picking out specific. This one picks out specific indices of the schedule array, but then these constants here end up being like hardware lines to pick out specific bits or do specific numbers of shifts. So yeah. Okay, this was old. So did I get that right? Oh, wait a minute. No, that wasn't old. No, that was old. So it's the outer one. I minus 16 plus the S0 term plus 7 plus the S1 term. I think that's right. So we'll move on. Moving on. So A through H. F, G, H. 5, 6, and 7. All right, here's the main compression loop. So they do it 64 times instead of 80 times. And I'm going to just pull this out. All right, let's implement the pseudocode here. So that term just goes into that. See, they're just pulling it out to make it easier to read. So really, there's just temp 1 and temp 2. Temp1 is used more than once, so I'm going to make a variable for that. Temp2 is only used once, though. So let's just skip to the H. So H equals G. G equals F. F equals E. E equals D plus this temp1. I'll just keep references to the code there. D equals C, C equals B, B equals A, and then A equals temp1. Actually, okay, we did need temp1. So it's used twice. We'll call it temp. Or can we just call it T? T plus, and then the T2 term. So we can compute T up here, because why not? T equals H plus the S1 term plus the CH term plus K of I plus W of I. Right? And then that's a const auto. And then the S1 term is rot E6 XOR rot E11 XOR rot E25. And then the CH term is, I believe that's bitwise and XOR bitwise not bitwise and G. I don't think we need to do an extra set of parentheses there. That's the CH term. Okay, temp2 term is the S0 term. Plus the maj term. S0. Rot A2 XOR rot A13 XOR rot A22 plus A bitwise and B XOR A bitwise and C XOR B bitwise and C. Phew. Okay, so I don't need this anymore, right? And that was the whole loop. We're done. And then they add, okay, I just need to add the 3 extra terms here. Okay, and then we append the terms together. Right. Okay, so we're using initializer list syntax, so it's a bit easier. I just need to add the extra terms. Hold on, wait a minute. Okay, yeah. 5, 5, 5, 5, 6, 6. IntelliSense is fighting me every step of the way. It's trying to say like, well, is that the variable you really want? Yes, it's the variable I really want. Are we done? Is that it? So I never really said so, but I don't claim this to be a very optimal solution. What I really care about is functionality first, then optimize later if I need to. You want to avoid the trap of premature optimization. You might spend like weeks trying to optimize something and find out, well, you only really call that once when you first start up, and then so it doesn't matter if it's optimized or not. Okay. It is not working. It's the correct length at least. At least we got that right. So So we'll just have to go through this painstakingly and find out what we did wrong. If I go here, and oh, my color key is wrong again. Is it just because the light keeps changing? The amount of light? Maybe I need a floodlight of some kind. Actually, I think what I'm gonna do is open the blind a little bit. Hold on. That work? Maybe a little bit. I'm dissolving, yeah, because the color key's too aggressive. So yeah, I can show you what it looks like without any color key at all. And then it's too bright. It's too inconsistent. The brightness level isn't right. Dissolving! I'm dissolving, my face melting. I'd much rather have my face dissolve a little bit than to have that blue stuff show up. You know, another thing I can do, I can just work with this color here a little bit. There we go. It's the amount of light coming in from different angles that's changing throughout the day. That looks better. Okay. Distraction out of the way. Let's go debug. So, our data is... What is that? Are we doing the difficult test first? I don't really want to do that difficult one first. Oh, this is SHA-1. I forgot to remove these. I want to see SHA-2. Okay, what is the message that we're getting to hash? Is the empty string. Perfect. So the length is 0. So it's going to put an 80 hex at the first byte. And then at the end of that chunk, it's going to put the length, which is 0. So the chunk looks like this. It has the one bit we appended, and all the way at the end, we have the message length, which is 0. I couldn't get any simpler. And then we put it all into those words. So the words array has that first one, which is, if I could show it in hexadecimal, it would be 8 and then 7 zeros and then a bunch of zeros. Oh, wait. Maybe that's the problem. Oh no, we haven't done that part yet. Right, so that's this part. So if I go to there, it'll have filled in all those rest of those words. Hold on a sec. All right. Yeah, so hopefully all these words are right. We should probably check it to make sure. I don't know about these. Some zeros in there. I don't know. Anyway, did I do something obviously wrong here? I guess it has something to do with what we did, but we can go to the end here. And look, see, the problem is, okay, let's just look at the first word. I will just type it into the calculator. Someone please help me out with VS Code showing in hexadecimal. 241889769 is 902D72FB. So does that match what we expect in our unit tests? That's the question. No, it should be E3B0, not 902D. Okay, did I get that right from here? Where is it? Test vectors. E3, B0? Yeah. Okay, so I didn't do it right. Something wrong in the hash function itself. Because that H0 term ought to match the first 4 bytes of the digest. So let's just look through the pseudocode. Make sure I initialized all those correctly. Whoa! I'll make it smaller, or a tad smaller. It's giving authorization for popcorn, apparently. All right. Really, I had to just copy these, right? And then just to make sure I didn't have a copy-paste mistake. So I can actually hover over these and VS Code will tell me that it's matching. Yeah, okay, so those are all right. Next part, these. I copied those verbatim, so those should match. Oh wait, hold on. Are those changed at all? I guess it would have told me because I made them const. It's not that we initialize them. These are constants. Okay, I'm just looking at this logic. Did anything... You guys can't see the right side of that. Did anything here differ from SHA-1? I don't think so. Okay. 64 entry, which is the W. Actually, why am I doing this chunk stuff and then the W equals chunk? That's sort of an unnecessary step, isn't it? Anyway, this puts it into chunk, hopefully correctly. Actually, it looked like it was correct to me. And then this is forming them into words. That should be fine. Actually, we did check that, right? This is potentially one thing where I have errors, though. So from 16 up to 63, so not including 64. How am I going to show this? How about we don't need that for now? And then I wish I could just... Well, I guess I can. Do that and then shift it over. Okay. WI is the S0 term. It's WI minus 16 plus the S0 term plus WI minus 7 plus the S1 term. The S0 term is WI minus 15 right rotate 7. XORed with the same thing right rotated 16. XOR with that right shifted 3. I need to make sure I understand right shift if that's correct. Like as in 0 should go into the 3 most significant bits, right? Okay. S1 is that same term, WI minus 2. Right rotated 17 and then 19 and then shifted 10. And all those XORed with each other. Okay. No, didn't see a problem there. Okay, now the main block. So basically H is G. Whoops, didn't mean to click that. H is G, G is F, F is E, E is D plus temp. 1. D is C, C is B, B is A is temp. Oh, hold on. I think this might be the problem. It's supposed to use temp 2. Temp 2 is calculated before B changes. No. Temp 2 relies on. Yeah, that's what it is. Temp 2 has a B and C term, and I've changed it before I've calculated it. So yeah, I was trying to avoid computing it and then using it if we only use it once, but I think we have to because it's computed before it's used, and it's used after the things that it's computed from changed. Yeah, okay, so I'm gonna make that one T1 and the other one T2. This is T2. All right. Maybe that was the problem. So we calculate those temp 1 and temp 2 terms. I didn't bother to use S1 and S0 because they're just used once. We calculate them all before we use or change them, right? We calculate them before we change anything. Just making sure, yeah. And then we start changing the terms. Okay, so maybe that was it. Yay! Do a little victory dance. Cool. And what's really cool is we had 3 test vectors in there, so it passed all of them. I was worried there for a second because I'm like, if I can't find what I did wrong in that code, I mean, I don't understand the algorithm. There's nothing I can look at runtime to figure it out. 3 happy dancers. Thank you, Rally Monkey. Oh, we really only had 2 vectors. Should I just add a 3rd? How long should we make it? We just need something to hash, right? And can I use that nice site I found? Oh, wait a minute. No, I don't. I don't need to. I have the power of Openssl. I just need to, again, turn off in my editor config, turn that off. Just for a moment, because I don't want a new line character added. And then in this folder, we'll make another file. Long text. Okay, what should we put in here? Something longer than the Fox stuff. Let's make one. Let's make one that's like similar to what they had in the SHA-1 test. Where was that? Down here. It was like the letter A repeated 1,000,000 times. There's also this long one. Let's do this one. Come on, Matt. Come on, pointer. There you go. We'll do that one. And then I'll have another one, even longer. Extreme text. Here's extreme text. Uptime, yes. I've been going for almost 3 hours. Hopefully it should finish soon because I'm hungry. I haven't eaten lunch yet. And that was the whole goal for today anyway, was just to get HMAC and SHA-2, at least SHA-256 working. Be a good stopping point. But yeah, I want to have that 1,000,000 A characters, I think. Hey, welcome folks from Jesse Skinner. How's it going? I'm just finishing up coding the SHA-256 hash function and hash message authorization code. Did I get that right? I'll show you guys what my plan today was. Hash-based message authentication codes. So yeah, I'm working on C++ implementation, or wrapper, so to speak, for hash functions and HMACs, because I'm going to be making my own wrapper for Amazon Web Service APIs, and they want you to sign every message with HMACs. So based on a hash, and the hash function they support right now is SHA-256. So, how was your stream, Jesse? What were you working on today? This is the first day I had this silly webcam, so apologies for the semi-transparent glasses at times. My color key isn't quite right. So yeah, I want a million A's. What's a good way to make a million A's? Well, I could start with 10, right? And then now I have 20, 30, 40, 50, and double that I have 100. And can I turn on word wrap? Toggle word wrap. Actually, this might not be so easy. It might be better to just make a short script that does this. I'm going to completely cheat. Watch this. So I'm going to say in this test, file f equals f open extreme.txt write, doesn't matter, text f write test vectors for dot input dot c string 1 million characters to f close f. I'll just let my test framework do the work for me. I misspelled that. Stream went well. You were just profiling the API usage, trying to identify bottlenecks. Pretty low-key stream. All right, cool. No silly webcams, only silly faces. I am not Canadian. I am from Southern California. Okay, so when I run that test, which is hash test, now it should have, I expected that to fail, but it should have made an extreme.txt that's 1 million characters long. So now I can totally use my new best friend tool and say SHA-256 on extreme.txt, and then I get that. So I can take that code and put it back into my test for SHA-2 and put that code there, and then use the same trick from SHA-1 tests for the input, and then build that. Hold on, I don't need the hack for this anymore. Build that guy, and now my test should pass. Right. Yay. Southern Canada is, well, I guess technically the US is Southern Canada, so sure. Oh, and Slayer's got to run? No, Jesse's got to run. Oh, see you, Jesse. Yeah, apologies. I have to look over here to see my chat right now, because, you know, pro streamer, not. And I might miss messages. It gets worse when I have a lot of viewers, because I miss more and more text and I feel bad. Okay. All right, so let's check this stuff in. Right, we added SHA-1. What did I do here? Oh yeah, that was some minor cleanup. We should check that stuff in first. So fix some documentation typos. Wow, the white screen really lights up my face, doesn't it? Okay. SHA-2. Add SHA-2. Only SHA-256 for now. Although since you guys are here from Jesse's stream, maybe instead of ending early, I will continue and make some mods to the SHA-2, maybe add the SHA-512. Do I write C++ for a living then? Yeah. Right now I don't have a job, but I'm planning to do independent consulting, and I'm hoping to leverage my experience in C++ for maybe some contracts in that. But you could also say a hobby is what you could make a living out of, or that there's some commonality between what you do for your hobby and what you do for a living. I don't know. I'm ranting. So yeah, what I did in my last job was a lot of C and C++ for making demo apps and prototypes for audio stuff. So we did a lot of things with 3D audio and other multimedia stuff too, like H.264 video and VoIP calls with prototype vocoders. So it kind of got me into learning lower level protocols like HTTP and VoIP like SIP and RTP. And so I've been learning how to program the Commodore using the Vice emulator. Wow. That's hardcore. Well, you'd be surprised though, like some languages just don't die. Like apparently Visual Basic still a big thing. And COBOL still around. So who knows? Maybe somewhere there is a need for a Commodore Basic coder. Okay, that was SHA-1. SHA-2 had the million character test. I don't think I need to have these other guys. Oh, I forgot to push that. PHP is still saying Fortran. Fortran. JavaScript, yeah. Well, JavaScript's not obscure. You just made a leap there, my friend. Fortran to JavaScript? Fortran is still alive and kicking, but JavaScript, it's still in its prime, right? In fact, it's still on the rise. I would not say the same thing about Fortran, though. Okay. Fortran's still hanging on just because of the sheer number of libraries and users out there, but I doubt anyone would want to choose. We don't want this change. I doubt anyone would choose to make a new project from scratch on Fortran unless the government's asking them to do it. Okay. I think what we'll do is we'll pursue the idea of making a template in order to clean up some of the boilerplate what we did in SHA-1 and SHA-2. So we had the actual hash algorithm, but we had these helpers that would converting between strings and bytes and stuff. And then in the HMAC, we had to program in the block size, and that ought to be something that the template provides, right? Not a language? Not a language. I'm missing the context for that. I'm sorry. Let's make a template. So I'm just going to take one of these header files and duplicate it. Do I want it? Yes, I want it to be a public template. Not SHA-3, although that's another hash function we could do. We'll call it hash template. I hesitate to call it hash because hash is the name of the library. How about hash? Hash. I was gonna call it hash template at first, but is that lame to call a template something with the word template in the name? Let's just call it hash. To be done with it. Hash. Oh, hold on. I didn't want to replace all that. After I make this template, though, I really do need to stop eat something. So I apologize. So this will probably take, what, another 15, 20 minutes? Declares the hash. It's going to be hash class template. Oh, hello, Stream Elements. You've been quiet the whole time. Yeah, so my goal was to have every once in a while a little timer pop up to let people know the page to get here. My notebook's public, at least for reading. All right, so we're going to zero all this. Oh, well, no. This is going to be built into our template. So template class, but really it's not a class. Standard function that returns a vector of bytes and takes a const vector of bytes as input. And that will be named H. Hold on, this is getting out of, a little out of the hand, so I will... If I do this wrong, I'll feel foolish and... Actually, that's about it. I'll feel foolish. Won't be the first time. So we'll call this hash. What other arguments? Okay, that comma doesn't go there, does it? I had too many of these. That's the problem. We need a hash function, and then we also wanted to have a block size. What if we should just call this hash function? Or function? Hash function? Block size, maybe? Hey there, Morlade. I can actually wave and say hi. Alright, so template class. This is where I kind of forget the syntax. Do I need to repeat hash function block size or just go into it? I think I just go into it, right? And then what I kind of wanted to do is build this stuff into it. These wrappers. So basically move that into here. Oh, okay. I could have just moved this and brace, couldn't I? This function computes. So these all become statics, right? No. Well, yes, because we put the body right in here. That's what we end up doing. These are our wrappers, and I'm going to change the order of this a little bit. This goes away because that's the hash function. And I guess, is this what we do? We say size t, static const size t, block size equals block size? Is that what you do? I forget. We'll see if the compiler accepts it or not. Okay, so I'm gonna take the wrapper stuff out. Actually wondering if the compiler will let me do that. Or if I'll have to have an instance. I think it's going to want me to have an instance, right? So I'll have to have a constructor. Yeah, so we'll probably need that. So it'll be like this, and then I'll have to have a constructor to fill it. So hash explicit. Like that. I think. And then let's see. Yeah, we're just removing the names of SHA-1. Because we're going to reuse this. That's what templates are for. Reusing stuff, right? So that is replaced with this. And then let's grab the other two wrappers out. Actually, that can't be static anymore, can it? because it's using that instance. Or, let me see if the compiler will let me do this. I don't remember, but let's say we actually don't have state. We just use that directly. Will it let me do that? In other words, the argument is a function, not a type of function. Wait a minute, no, this is a type. I don't think this is gonna work. Well, we'll see. We'll get everything set up and then see that it fails. Alright, so the hash function goes in place of where we actually were calling the old hash function. And I should do the right thing in making sure I include everything. Functional. Make sure I include everything I use. Okay, there we go. A non-type template parameter may not have class type. So, really? Is it just type name? Okay. I gotta look it up. Move this off screen. I've been doing searches off screen because I noticed something about Google search I don't like. Okay, let's read this. That's a C style function pointer. Oh, right. Okay, so if that's right, then I don't use this. This is, right, that's an implementation of a function object. So what we really want is it to actually be a pointer to a function. Because a function, standard function is a way to do that, right? You don't have to have, say, type name. Okay, great. It's just that there needs to be a star in front of the name, hash function, and then like that, right? Okay, cool. So then the way they use it is they just, all right, okay. That works. Let's try that. So the way I would try that is in SHA-1, I can just get rid of these ones. Get rid of this guy. And then just call that SHA-1. And then, yeah, basically do away with all this stuff. Because we don't need it. SHA-1. Which is nice because it's just the hash function alone. And then the magic would be basically where we use it. We would have to say, well, that, and then we would say hash SHA-1, comma, let's make it constant. It really does belong here, right? So we'll say this is the block size in bytes used by the SHA-1 hash function. Static, or really const, expr, SHA, size t, SHA-1 block size equals 64, right? And so then we can just say that here. String to string. That's what I want to say, although it's sort of a long way of saying it. Too few template, class template. I thought I gave it exactly 2. Is that how many I had? I don't get it. What's wrong with that? I don't know. But let me fix the other one. And build some bitch. Oh, sorry. I shouldn't say that and have my stream family friendly, should I? My apologies. Okay, I don't care about HMAC tests for the moment. Too many arguments for function-like macro. Too many arguments. Okay, let's, to understand this, let me pull this out. Copy that, and that's the template. So, type diff SHA-1 hash template. Or hash SHA-1 class. Oh, is it because I'm missing that? I think that's why. No, still too many arguments for this. So what does that type look like? Okay. Yeah, so I should be able to do this. Okay, what if I just replace this with this? Cannot access private member. Okay, yes, I did do that wrong, didn't I? Let's make that a struct. What the F is going on? You've been learning Python for 2 months. How long does it take for you to understand this? Probably around 2 months as well. It's just a different language. It's got different rules, different syntax. Oh, yeah. Okay, it got past that. So that was the answer. It was that I had to put that in there. Actually, I'm surprised it didn't just let me do this in. Actually, it's still giving me problems. I'm not seeing it. I think. Yeah. Okay, that's old. Okay, so it should accept this in place of that. It's not though. Okay, it has something to do with the macro. So we'll just leave it like that and move on. So it'll be the same kind of thing. Actually, I can just make this up here, right? Really, this hash is not so much, it really is just helpers, right? It's something to hold the block size and the, actually, this still seems like it doesn't belong. Hmm. I think I know how I'm going to use that. So we don't really need that. It's not so much that it's the hash. It's like the hash helpers. I don't know what I want to call it. Not hash though. It takes a hash function and provides a bunch of helpers that you can apply with it. Actually, why am I even using a template? This is already just a function pointer. I could just make these individual templates, couldn't I? Yeah. Yeah. Okay, so although it's not so cool, I'm gonna, instead of having a template structure, I'm just gonna make these template functions. So I know what we'll do. Let's make this a type def first. Okay, comment later. And then, yeah, we don't need this. These all become template functions. So static? No, not static. Type template. Type name, or really hash function. Hash. And then we just put hash in here, right? Template functions. So yeah. Template doesn't have to be a class, it can be a function. So those are template functions. I think this will work because it'll look more natural, because in the test we can say that it is not SHA-1. What even happened to that? I just deleted it, I guess. How do I get it back? Oh, I put it up there. So it's really hash string to bytes, string to string, templated with hash SHA-1, and then the rest of it. I didn't like that type def. Oh, yeah, that doesn't exist anymore. I think we're good because it's getting down to here now, so just need to fix this up. So that, yeah, that looks a lot better. Well, it's rearranged a little bit. It's like that. Cool. String to bytes. Oh yeah, I don't, that's extra. Still 36 doesn't like. What doesn't it like about that? Ambiguous. It's ambiguous about it. Oh, return can convert vector to string. In hash, okay, it's in the template itself, 56. Oh, yeah. Oops. I messed that up. So let me look at SHA-2, the string to string one. Oh, it uses the other template. So it's a two-step thing. Okay, we can do that. We can just say this. Return bytes to string of hash data as vector. I think. Yeah, see, now it's just complaining about HMAC tests because we haven't fixed that up yet. HMAC tests. Yeah, so I can also templatize the HMAC stuff. I can do that. I'll do that Next. So yeah, this is what changed. So it's this got moved around. So it's that templated with that. Hi, Breeze. How's it going? Okay, I did that multiple places. Yeah, and to use this template, I'm going to have to include the template header. So that was hash. Cool. Now we're... Make sure that we didn't break anything when we run our unit tests again. Didn't break anything. Okay, so now I can do the same thing with SHA-2. I can clean up SHA-2. It no longer needs to have the same wrappers that SHA-1 also had. So yeah, we can just remove all this stuff. We don't need bytes to string here, string to string. And then this simplifies down to just SHA-256. And then we can remove this other wrapper too. And then go into the body code and remove these redundant wrappers. This is just SHA-256. And then get rid of this wrapper. And then I just need to go back to the tests. Pull in the function templates. And then use them down here. So this is hash string to string. And then just give it the hash function. There we go. And then this one. This is string to bytes template. With that hash function. Cool. Nothing broken. Good enough to check in so far? I think so. Hash. So what did we do here? We removed these redundant... Actually, I need to add that in SHA-2. We removed these redundant wrappers that convert string to string, bytes to string to bytes. And so that now the hash function is just doing the algorithm. And yeah, before I commit that, I want to get the block size. So SHA-1's header define the block size. And SHA-2 header does not, so we'll add that here. So this is the block size in bytes used by the SHA-256. That also happens to be 64. Alrighty. And yeah, I want to check that in. I should probably that shouldn't have broke anything, of course, but we'll build to make sure. So I think what I'll do is I'll try to make a template for the HMAC and then I'll wrap things up for today. So I can go, it's kind of late to eat lunch. I'll eat a light lunch and then, I really should eat lunch before I start streaming. Anyway. Or lunner, yeah. Like lunch and dinner. Okay, so this is refactoring, really. Make template functions to do string vector conversions for hash functions. Yeah, it's essentially what I did. Commit that guy. And then push. All right, so HMAC. Yeah, actually, I wonder, do I actually need a template here? I don't think I do. I think all they really wanted to clean up was I do not need this output size, so I'm going to remove that. So turns out HMAC doesn't really need to know the output size. It just needs to know the block size. So Remove blocks, remove output size. Doesn't need to know what it is. Yeah, all of these do not need to be given the output size anymore. Why am I using standard each time? It's just a personal preference. I don't like using, you could do using namespace std. So there's two reasons I don't like to do that. I think it's rude in the header file to do that because you're basically imposing on anyone who's using your header that they'll get the standard namespace collapsed into the global namespace. So sort of rude to do in a header, so I definitely won't do it in my header. I'll just keep it unsquished. And I could, in my CPPs here, remove the standards by doing a using namespace standard, but this is more personal preference that I like to, I don't like to do using namespace standard because it's gonna collapse namespaces and it just doesn't feel right to me. I like knowing that when I'm doing this that I'm pulling from the standard C++ library. For the same reason, I don't do using namespace for my own namespaces, so that my test will say hash : : It's kind of a reminder that this thing is in that library. So this reminds me the string is in the standard library. Vector's in the standard library. So, but I'm not trying to say you should do it that way. It's all personal preference. Header files, though, I think it is sort of nicer not to do using namespace because to do it would be imposing on your users that they get the standard namespace squashed into your library's namespace, or even the global namespace. Same reason I always put stuff in a namespace in a header file is I don't want to impose on my users that stuff is added to the global namespace. So, yeah. You could have adverse effects in files using, yeah. So I really don't want unexpected side effects or consequences that aren't expected. Yeah, I never used output size, so I don't actually really need to change any code, do I? Just build that and make sure it's, oh, hold on. We got errors. Oh, right, it was forwarding output size, which we never used. And it's still in the implementation, so we just remove it everywhere. Yeah, we don't need to capture it because we don't use it. Yeah, I guess there was stuff I needed to change. Cool, everything still works. I'm gonna just run all my tests for all of the stuff I've done over the last 3 or 4 months. Make sure it all is still not broken. Good. And we'll check that in. Hold on. I need to make a commit before I can push it, right? Right, so we're removing... Yeah, so HMAC. Output size removed because it's not needed. Okay. Make sure I didn't touch anything else in solution here. So yeah, it'll probably be wrapping up soon. I hope you guys enjoyed watching. And hello. Enjoyed the face cam and all that. It's brand new. I've done 66 streams without anyone seeing my ugly face, and now you can, and you can't throw vegetables, haha, but you can at least be horrified by how I actually look. Yeah, so going back to the plan, we're pretty much done, right? Because all I really intended to do today was implement SHA-2. Well, I said SHA-2, but I really only needed SHA-256, so it's sort of a cop-out. But we implemented SHA-256, and we added hash-based message authentication codes. Probably what I'll work on next time is signing AWS API calls, so that'll be fun. Although I'll have to be really careful about what I show. You have to be always really careful when you have keys and stuff that are used live. I know what we'll do. we'll use the test suite that Amazon gives, and we'll just test against the test suite. So we'll be doing that next time. I'm not ugly? Well, thank you very much. So yeah, hope you enjoyed watching. Let's see who else is who else is streaming that I can maybe introduce you to if you haven't seen them. I don't know a whole lot of coding streamers, but I do know a few. Actually, we have a choice here. So I see both Simuleos and Adam13531 on right now. Does anybody have a preference? Maybe we'll go host Simuleos unless someone speaks up because I haven't hosted him in a while, I think. Yeah, so I'll give you guys the link to it. We'll see what. Let's actually let me look. I'm peeking off stream to see what he's working on. He's just working on his algorithm archive. He's an interesting streamer because he's got like a continuous dialogue with the community. I couldn't do that and keep up for hours and hours. So he's interesting. So let me give you the link to that, and we'll go say hello. So that's where I'm gonna host him, and otherwise, see you guys later. Thanks.